Halogenoalkanes are important chemicals in organic synthesis. The conditions of the reactions affect the products that can form. Some reactions of the halogenoalkane 2-bromobutane are shown below. Give the reagents and conditions for reaction 1. So reaction 1 is, the reagent then is ammonia, and I'm making just the primary aim, and it's not going any further, therefore it needs to be in excess. Okay, so 2 marks, 1 for that and 1 for that. Part B, if the conditions of the reaction are altered, a compound with the formula C16H36N. Okay, so how many carbons do we have coming off the nitrogen here? So we've got 1, 2, 3, 4, and in fact let me get the highlighter on, and it joins at that point there, which is where that bromine is there. So this is the one where if you have the excess halogenoalkane, you have multiple substitution of each of the hydrogens in here. So it's this reacting with this again, then again, but then because I've got 16 carbons, which is 4 lots of the 4 that are available here, it's going to actually form the quaternary salt. Okay, so at the nitrogen here, so what we've got already is, so we've got this already coming on carbon number 2, so there's carbon number 2 there. So I need to repeat that all the way around here. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then I can put the plus in the brackets on the outside, or I can put the plus here. C, reactions 2 and 3 both use potassium hydroxide as a reagent, but are carried out under different conditions. For reaction 2, give the conditions needed for compound L. So reaction 2, so this is forming the alcohol, so this is going to be aqueous. Okay, so the conditions is going to be aqueous and heat or warm. And then the name of the type of the mechanism is nucleophilic substitution. And then the mechanism here, so if you don't like skeletal, then don't convert it to structural, or a little bit of both displayed. So OH minus needs to be on the oxygen, lone pair needs to be here, curly arrow from there to there, curly arrow from here to here. Just watch out for connectivity as well. Remember that carbon to the oxygen on the alcohol needs to be pointing to that oxygen. Okay, and that gives us that. So in reaction 3, compounds M, N and O are formed, all having the molecular formula C4H8. Compound M does not exhibit stereoisomerism, but it is a structural isomer. N and O are a pair of stereoisomers. Let's have a look at reaction 3. Okay, so reaction 3, let me just rub a few bits out over here. So reaction 3, so this is the elimination reaction. So I'm going to form a double bond here. Okay, now that's the one that obviously I'd have 2 hydrogens here, so that's not going to exhibit isomerism. But I'm also going to have, if I draw it in another colour, I'm going to have a double bond there as well. So and that will give me EZ isomerism. Okay. So let's go back to where the question is. So let's do the definition first for stereoisomers. So it has the same structural formula with a different arrangement of atoms in space. Okay, so compound M, 1, 2, 3, 4, is going to be that one there with the double bond on this side, so that's butanene, and then N and O, 1, 2, 3, 4, with the double bond here. So that one is the E isomer, but then I can have that one as well, which is the Z isomer. Part E, compound K and L can both react with ethanol chloride in a nucleophilic addition elimination reaction. So we need to do K with ethanol chloride. So K, so NH2, lone pair on here. So curly arrow from there to there and there to there. So there's 2 marks, one for that curly arrow, one for that curly arrow. That's going to give me an intermediate. Put the hydrogens over here so I can do my skeletal bit down there. Don't forget the plus on the nitrogen, and then I need 3 arrows on here, so one from there to there, one from there to there, and either one of these. So there's 1 mark for the correctly drawn intermediate, 1 mark for the other 3 arrows, which gives me CH3, CO, and then NH, which gives me that. Okay, and then part 2, name the homologous series for the reaction of compound L. So that was going to be the oxygen in place instead. So here I'm going to have an oxygen instead, which is going to give me an ester.